At 16:30 hours, an American F-35 Lightning II was screaming across the Khuzestan province at 120 meters toward the Karun Dam, now a critical Iranian logistics choke point supporting regional operations. While the pilot had successfully used terrain to stay hidden so far, this would all change in a matter of minutes. Unknown to the pilot, 4 different Iranian radar systems already had him their processing queue. An S-300 PMU-2's phased array radar had initiated track protocols at 64 kilometers. A Tor M1 system was analyzing returns from the south, and a Buk M1 was warming up to the northeast, enough overlapping missile coverage to turn any aircraft into aluminum confetti. The pilot's eyes locked on the reconnaissance feed streaming to his helmet-mounted display. The dam had been turned into a superhighway of Iranian logistics trucks and Revolutionary Guard Corps command vehicles. So in order to complete the mission parameters, the strike had to happen now. The F-35 was following the Des River Valley using the natural depression in the terrain to mask his approach from the Iranian air defense network. Flying at 750 kilometers per hour, just 120 meters, he had one significant advantage that no previous generation fighter possessed. The F-35's 5th-generation stealth design was not merely about paint and angles. The airframe itself was constructed with composite materials that absorbed rather than reflected radar energy. The internal geometry of the fuselage, the shape of the intakes, even the placement of the cockpit, all worked together to create a radar signature smaller than a marble when viewed from certain angles. But that invisibility would end in roughly 10 minutes when terrain limitations forced him into open skies. After that, the final 12 kilometers to the target would be a calculated gamble against one of the world's densest air defense networks. Through the heads-up display, the landscape rushed past with merciless speed. Date palms appeared and vanished faster than conscious thought could process. Power transmission lines strung between concrete pylons flashed past at bone-jarring intervals. The pilot was flying on instinct and muscle memory honed through hundreds of combat training sorties. His hands made corrections before his brain consciously registered the need. This wasn't flying in any classical sense. It was controlled falling with style, but avoiding becoming one with the Iranian countryside was becoming secondary to his mounting concerns about surface-to-air threats. The F-35's integrated defensive avionics suite was painting threats on its panoramic situational awareness display like a very angry constellation. Unlike the older generation tactical jets, the F-35 didn't just receive warning signals. Its advanced electronic warfare suite was actually identifying, categorizing, and predicting threat response times for every radar emission it detected. Each strobe showed not just direction but probability of intercept. The pilot counted the radar's repetition frequencies like astronomers measuring stellar distances. The S-300 to the northwest was giving him slow, sweeping search patterns across a wide area. The pulse repetition frequency suggested it was still in acquisition mode, not yet fully focused. A Tor system to the south was creating a more coherent beam, suggesting target tracking operations, and the Buk to the northeast was coming online, its radar warming through power cycles. This was a network problem now, not just individual threats. Iranian air defense doctrine had improved significantly in recent years. They weren't operating in isolation anymore. Multiple systems were connected through a command and control network that could coordinate firing solutions and prevent saturation. The pilot understood this reality intimately. He was not just evading a radar beam. He was trying to stay invisible to an integrated air defense system worth more than $1 billion. That calculation drove his next decision: stay low for 10 more minutes, maintain the stealth profile, and pray the valley didn't close before he could execute his strike. As the pilot was working through this tactical mathematics in his head, the AGM-50A8-ER cruise missile on his centerline weapon's hardpoint was running continuous diagnostic checks. GPS receiver locked onto 14 satellites, each signal validated against civilian and military navigation networks for any indication of spoofing. Inertial navigation system aligned to within 3 meters, integrating accelerometer readings with the aircraft's own navigation data. The cruise missile needed specific conditions to reach its target with precision. The weapon guidance system needed a precise GPS coordinate, perfect inertial alignment, and a confirmed target image in its terminal seeker database. Conditions the pilot didn't have at 120 meters altitude, the dam still 23 kilometers away. But thinking about now was like worrying about the aircraft's fuel economy while the stick shaker warned of structural G-limits. First survive the approach, then figure out how to deliver a $500,000 weapon with a stealth jet that had only recently achieved operational capability in this particular theater. Complicating everything further was his fuel gauge showing 8,400 kilograms remaining. The forward operating base was 86 kilometers away. At current consumption rates, that gave him exactly 22 minutes over the target area before he was facing a fuel emergency. 22 minutes sounded like plenty till until you factored in combat maneuvering. Every evasive turn, every climb to avoid terrain, every minute at maximum thrust for weapons release would eat into that margin catastrophically. The Pratt & Whitney F-135 engines were thirsty at low altitude, consuming fuel at rates that seemed to defy physics. One extended evasion sequence could eliminate his entire safety margin. One miscalculation could force a landing in hostile territory or ejection over enemy-controlled terrain. 23 kilometers to the dam, but the valley closure would force him into open airspace much sooner. The drone overhead showed no vehicle movement at the dam in the past 5 minutes, which either meant they were extremely disciplined or they'd been warned. The pilot increased throttle slightly, accelerating to 850 kilometers per hour. Every second he saved now was a second he could spend in the target area, or a second less being tracked by the integrated air defense network. In combat aviation, seconds translated directly to survival. At 16:38 hours, the pilot reached the point where the river valley began its inevitable opening into the flat Khuzestan plain. What radar invisibility meant became suddenly terrifyingly clear. The F-35's electronic warfare suite went from showing lazy search patterns to what sounded like an angry hive. 8 different radars suddenly spiked in intensity simultaneously. The S-300 that had been casually sweeping across the region snapped to a focus beam pattern. The signal went from a wide searchlight to something closer to a laser pointer. The pilot had gone from invisible to potentially visible in seconds. The locked tone in his headset changed character from intermittent chirps to a pattern that suggested imminent action. Here's how the F-35 knew it was in trouble. The ALQ-130 Defensive Electronic Warfare Suite had passive antennas distributed across the aircraft specifically designed to detect and characterize radar emissions. They functioned like acoustic sensors tuned exclusively to radar frequencies. When a radar beam swept past once every few seconds, the F-35's system registered search operations. The audio warning in the headset was a slow, repetitive beep. When that same radar transitioned to multiple hits per second while maintaining focus on the aircraft's location, the warning shifted to sustained tracking. The beeps accelerated when a radar locked on to a firing solution, transmitting a narrowly focused beam that didn't release its lock. The system recognized imminent missile launch. That's when the pilot heard a solid tone that bypassed the auditory system and created a visceral sense of danger. The S-300 system operated in frequencies the F-35's passive radar warning system could identify by the unique frequency signature and pulse pattern. Right now, it was screaming that an S-300 had achieved track lock. The engagement envelope of the S-300 PMU-2's 5B-55 missiles had a stated range of 150 kilometers, but at low altitude, considering terrain masking, Earth curvature, and the F-35's small radar cross-section, effective range was compressed to perhaps 70 kilometers. The pilot was at approximately 68 kilometers. The mathematics was brutally straightforward. He was within effective firing parameters. The only reason missiles weren't already airborne was the Iranian operator's reaction time and the inherent delay in transitioning from detection to launch authorization. Could estimate maybe 9 seconds before launch commands were transmitted. The pilot executed a hard right turn, banking to 40 degrees while maintaining altitude at 120 meters. The maneuver pulled approximately 6.5 Gs against his body. The entire aircraft and pilot became a mass accelerating toward the ground, held in level flight only by the vertical component of the lift vector. The maneuver put his velocity vector perpendicular to the incoming radar beam. A Doppler radar, which most modern systems employed, relied on detecting the frequency shift of moving objects. When an aircraft directly away from a radar antenna, the reflected signal showed one frequency. When it flew toward the antenna, the frequency shifted in the opposite direction. But when the aircraft's velocity vector was perpendicular to the radar beam, the aircraft moved at the same speed relative to the radar antenna as the ground directly below it. Zero radial velocity meant no frequency shift. No frequency shift meant the F-35, with its already diminished raw cross-section, registered as nothing more significant than stationary terrain clutter. The lock broke, but the maneuver cost him dearly in terms of tactical position. He was now heading away from the dam, his planned approach vector compromised. The intensive maneuvering burned through fuel reserves he couldn't afford to waste. Worse, everyone on the Iranian air defense network now knew approximately where he was. Suddenly, a Tor M1 system to the south lit up. Targeting data came alive on his electronic warfare display. The Tor was fundamentally different from the S-300. While the S-300 used active radar homing guidance, where the missile's own seeker tracked the target independently, the Tor employed command guidance architecture. The missile itself was essentially a guided projectile. It didn't think. It didn't have its own seeker head making independent tracking decisions. Instead, the ground-based radar tracked both the missile and the target aircraft, computing the intercept solution through continuous calculation and sending course corrections via data link every 0.5 seconds. This made the TOR nearly impossible to jam through conventional means. You couldn't confuse a missile that wasn't making thinking decisions. The only defense was breaking the ground station's radar lock entirely, or creating a situation where continuous course corrections became mathematically impossible to compute. The pilot snap-rolled the aircraft to inverted orientation and pulled the nose hard toward the Earth, descending from 120 meters to just 40 meters in 1.8 seconds. The ground rushed closer with insane velocity. Trees and agricultural structures flashed past the canopy enough that individual details became visible. As he dove deeper into the terrain masking layer, his right hand found the countermeasures control panel, triggered the chaff dispensers in rapid succession. Bundles of aluminum-coated fiberglass fibers erupted from the aircraft in coordinated bursts. The fibers were cut to precise lengths, carefully tuned to half the wavelength of the S-300's operating frequency. To the S-300's phased array radar, the chaff cloud suddenly appeared as an enormous target, spreading across the sky like a metallic mushroom cloud containing multiple apparent contacts. But the TOR system operated it in a different frequency band entirely, requiring chaff cuts to different specifications. The pilot triggered the second chaff dispenser, releasing fibers calibrated to defeat TOR band frequencies. Now he had countermeasure coverage across the critical radar bands, creating what air defense experts called a chaff corridor, a tunnel of electronic deception he could hide within. The TOR's radar struggled to maintain lock within the chaff cloud. At just 40 meters altitude, the F-35 might as well have been driving a very fast ground vehicle. Radar returns from the Earth and vegetation at close range created overwhelming clutter that buried friendly returns. Every radar operator understood this fundamental limitation. Low-altitude flight turned the air defense system's greatest advantage into a liability. But the pilot wasn't finished with his defensive suite. His left hand moved to the electronic warfare pod activation switch. The ALR-56 electronic warfare suite came alive, analyzing the TOR system's transmitted frequencies with superhuman speed and generating false radar returns technique called range gate pull-off. This was electronic warfare at its most sophisticated level. Imagine the TOR's radar antenna as a searchlight beam probing the sky. When it found the F-35, the radar's fire control computer focused intensely on that specific point in space, creating a narrow tracking gate. The electronic warfare system generated a false target signature, a bright electronic decoy that appeared on the TOR operator's scope right next to the real aircraft. Then the jamming signal gradually moved this false target away from the real aircraft's position, like sliding a bright light across a dark wall. The radar's tracking computer, programmed to follow the strongest return, automatically tracked the decoy while the actual F-35 disappeared back into terrain clutter. On the TOR operator's display screen, what appeared was a single target gradually climbing and moving away. Meanwhile, the real F-35 remained at 40 meters, heading in a completely different direction, invisible within the chaff and terrain return chaos. The TOR operator was now tracking an electronic ghost that didn't exist while the real aircraft vanished like smoke in the wind. But flying at 40 meters required a level of concentration and precision that bordered on the superhuman. One unexpected tower, one miscalculated terrain feature, one moment of attention drift, and the aircraft would become part of the landscape in a way that would require detailed accident investigation to explain. The pilot pushed throttles forward slightly, climbing back to 60 meters to provide slightly more buffer. The release point was now 15 kilometers ahead. Whatever tactical decisions he was going to make, they had to happen immediately. The dam release coordinates were locked into the weapon's guidance system. The targeting geometry parameters were calculated. The weather data was incorporated into the trajectory prediction model, but he still needed to accomplish the actual delivery phase. The pilot made a decision that would have earned him a failing grade in any formal flight evaluation, but might keep him alive in combat airspace. Instead of maintaining tactical stealth and choosing a cautious approach, he was going to create absolute chaos. If the entire Iranian air defense network was shooting at him simultaneous, no one system could coordinate with the others. The network would suffer from mutual interference and contradictory firing solutions. It was the aviation equivalent of starting a bar fight, where everyone was too busy fighting each other to organize an effective response. His right hand moved to the throttles, ready to advance them to military power. His left hand gripped the stick, prepared for what fighter pilot instructors called gross maneuvering and what actual pilots called controlled violence, becoming a smoking hole in the ground. 12 kilometers now from the minimum release point. The next 90 seconds would determine whether this mission became a success or a cautionary tale in military aviation history. The fuel gauge showed 1,650 kilograms remaining. Still enough time to get back to the forward operating base if nothing catastrophic happened. But in combat, something always goes wrong. The only question was how wrong and whether the pilot could survive it. At 16:40 hours, the pilot executed a maneuver that would make everything threat receiver on the Iranian air defense network lose coherent tracking. He pushed the throttles to full military power and pulled those toward the vertical, transitioning from terrain masking to a climbing attack profile. The twin Pratt & Whitney F-35 turbofan engines roared to maximum thrust, their combined output generating over 40,000 pounds of total force. The aircraft went from invisible clutter to broadcasting its position like a neon sign in darkness. Every radar operator within 120 kilometers suddenly got the target they'd been hunting for. Inside the S-300 command vehicle, the operator's eyes widened as their displays transitioned from uncertain ground clutter to a clear, bright, rapidly climbing contact. The target altitude was increasing through 500 meters. Rate of climb was computing at 280 meters per second, which was genuinely extraordinary. The fire control computer began calculating a new intercept solution, but the target's continuously changed trajectory meant every 2 seconds produced a completely different firing solution. The operators selected 2 missiles from their launch vehicles and initiated the firing sequence. The authorization came through from the battalion commander. Missile doors hissed open. Target tracking data uploaded to both missiles' guidance computers. Launch sequence initiated. 5-4-3. The climb was vertically insane. From 40 meters to 200 meters in 19 seconds, while pulling sustained 5 Gs, the pilot's body weight quintupled. His arms felt like they were constructed from lead. His head like someone was standing on it with full force. His G-suit inflated against his legs and abdomen like a python constricting its prey. At sustained 5 Gs, gray out was beginning. The periphery of his vision was fading into tunnel vision. 6 Gs, color perception would begin to fade. At 7 Gs, the tunnel would constrict to a narrow point. At 9 Gs or beyond, G-induced loss of consciousness would come within seconds. He was riding the edge at 5 Gs sustained, buying altitude with his remaining consciousness as the G-suit strained to maintain blood flow to his brain. But the maneuver had brilliant tactical logic underlying its apparent insanity. By going vertical, he made himself impossible to ignore, but also impossible to predict for computer-based trajectory analysis. The pilot added a barrel roll to the climb, corkscrewing upward in a helical pattern that defied easy prediction. To the Iranian fire control computers, his trajectory looked like spiraling vine climbing an invisible wall. These systems were programmed to calculate ballistic intercept points. Something traveling at X speed and Y angle would be at position Z in TT seconds. But the barrel roll meant constantly changing angles, velocity vectors that shifted direction every second. The predicted intercept point moved in geometric circles, never stabilizing long enough for a clean firing solution. Air defense operators were forced to continuously update their firing solutions as the aircraft's altitude increased by 250 meters per second. Its heading rotated 360 degrees every 4 seconds, and its G-forces made its acceleration characteristics non-linear. 3 different fire control radars achieved missile lock simultaneously. The S-300 to the northwest, a Buk M1 to the northeast, and the persistent Tor system to the south. The electronic warfare display wasn't showing individual threats anymore. It just screamed a solid tone that would have been called a launch alarm if there was such a thing. The pilot's response was to roll inverted at the apex of the climb and pull through the horizontal, creating a trajectory that looked like someone's incompetent drawing of a loop-the-loop. No computer predictive algorithm expected that maneuver because no rational pilot would ever execute it in a high-threat environment. At 200 meters, inverted, nose pointed at the ground, the pilot had achieved the tactical geometry he needed. The JASSM-ER weapon system displayed green across the entire test matrix. The inertial navigation system was aligned. The GPS signal was strong and validated. The weapons seeker was ready. But he was also centered simultaneously in 3 different missile engagement envelopes with high probability that missiles were already transiting toward his position. The electronic warfare system couldn't differentiate between tracking and active launch phases. It just screamed that an immediate retirement from combat flying was a distinct possibility if tactical conditions didn't change in the next few seconds. Time to release or abort. No gray area, no middle ground. The pilot rolled upright and held the aircraft level for exactly 3 seconds. In those 3 seconds, the JASSM-ER executed its complete initialization sequence at electronic speeds. First, the GPS receiver validated its position against 12 satellites, cross-checking each signal to ensure none were spoofed through Iranian jamming. Second, the inertial measurement unit aligned its accelerometers with the GPS data, creating dual redundant navigation. Third, the jet engine per final continuity check on its fuel injector and starter circuits. Fourth, the target seeker performed a complete calibration cycle, extending its optical windows and cooling its sensor package to -45 degrees Celsius. Fifth, the flight control computer loaded the target coordinates and calculated the optimal cruise altitude and velocity for fuel efficiency. Sixth, the warhead completed a safe arm verification sequence, all systems green, fully ready for release and powered flight. Time elapsed exactly 3 seconds. Meanwhile, 2 S-300 missiles had separated from their launchers, accelerating upward at 1,000 meters per second toward the F-35's current position. The 555 missiles were massive, each 7 meters long, each accelerating at approximately 25 Gs. Each carried a 180-kilogram warhead that didn't require direct impact to inflict catastrophic damage. A proximity fuse would detonate the warhead at ranges up to 25 meters, sending 18,000 fragmentation elements in a lethal sphere capable of killing at distances up to 40 meters. The missiles were burning fuel fast, already displaying the characteristic rocket exhaust trail visible against the clear sky. Time to intercept: approximately 42 seconds. With incoming missiles confirmed, the pilot pressed the weapons release button. 580,000 pounds of French-American engineering separated from the F-35's centerline pylon. The aircraft jumped upward as if someone had removed a heavy backpack. Suddenly more agile, suddenly faster, suddenly more maneuverable. The instant the weapon cleared the fuselage, the pilot rolled inverted and pulled toward the earth with everything the airframe could handle. 9 Gs, approaching the structural limits of the F-35's composite airframe. Something in the tail section made a sound that was almost inaudible, something between a creak and something worse. The pilot ignored it. The aircraft was bending but holding. Bent was infinitely better than exploding. The dive took him from 4,200 meters to 300 meters in 8.2 seconds, accelerating through Mach 1.2 flight. The wind was shaking the aircraft with tremendous violence as shock waves formed and collapsed around the control surfaces. The airspeed indicator showed Mach 1.25 and climbing. The transition through the sound barrier was rough, shaking the airframe like a dog shaking off water. The S-300 missiles tried to follow but couldn't match the trajectory change. They'd been aimed at where the aircraft would be if it maintained its climb or flew level. Nobody, human or computer, had predicted a supersonic dive toward Earth from 4,200 meters. The missile seekers attempted to track but lost the target as the F-35 disappeared below their minimum tracking angle. The missiles continued on ballistic trajectories, searching for a target that was no longer where their guidance systems predicted. They self-destructed at 6,500 meters, their fuel reserves exhausted, their mission incomplete. The JASSM-ER's solid-fuel rocket motor had ignited the moment it separated from the aircraft. The cruise missile was now accelerating upward while the F-35 was diving toward Earth at supersonic speed. Two objects that moments earlier had been unified were now heading in completely opposite directions at maximum velocity. The climb towards 6,500 meters, trading kinetic energy for altitude, preparing for its terminal dive phase. The pilot leveled off at 80 meters, threading between hills and using massive terrain features to mask his escape route. The incoming threat was now behind him, but fuel had become his immediate enemy. The military power climb and subsequent evasion had consumed 1,400 kilograms of fuel in just 27 seconds. His fuel state was now critically low. Home was 168 kilometers away through hostile airspace. Simple mathematics suggested he had approximately 11 minutes of flight time remaining before the engines quit for lack of fuel. 11 minutes had to be enough to get home, or he was going to be ejecting into territory controlled by the Iranian Revolutionary Guard Corps. Behind him, a Buk M1 system fired a missile at the JASSM-ER, mistaking the cruise missile for the fighter aircraft. The defensive systems radar had lost track of the F-35 in the dive and chaff corridor, but detected a bright contact climbing toward high altitude. The Buk's targeting computer, programmed to engage ascending contacts, fired an expensive missile worth approximately $3 million at a target that was already on a ballistic trajectory toward a fixed target. It was like shooting at a falling rock with a rifle. Technically possible, but the odds were infinitesimally small, would waste resources and provide no tactical value whatsoever. The dam was less than 70 seconds away from discovering why military infrastructure shouldn't share locations with command centers. Within 45 seconds, the JASSM-ER reached its maximum altitude of 6,100 meters and tipped into its terminal dive. The optical seeker activated, scanning the ground below in both visible infrared wavelengths simultaneously. The seeker's thermal detector array was cooled to minus 45 degrees Celsius, capable of detecting temperatures of 0.05 degrees. The dam appeared as a brilliant white signature against the cool blue of the water below. 8 hours of direct sunlight had heated the concrete structure to 38 degrees Celsius, while the water remained at 16 degrees. The temperature differential was approximately 22 degrees, creating a thermal contrast that looked like someone had painted the target in bright paint visible only to infrared cameras. The seeker's computer analyzed the thermal pattern, comparing it against preloaded target templates in its memory. Linear structure confirmed. Temperature gradient consistent with reinforced concrete confirmed. GPS core coordinates were within 8 meters of the target center confirmed. The cruise missile made a micro adjustment moment correction, just 1.3 degrees, now absolutely certain it had the correct target locked. The JASSM-ER accelerated through 280 meters per second, then 310, then 340 meters per second. At this velocity, control fins made millimeter-scale adjustments to maintain perfect trajectory alignment. Each microscopic movement changed the predicted impact point by meters. The GPS system maintained continuous updates to the inertial navigation system. The weapon's dual redundant guidance system agreed on a single outcome with absolute certainty. Impact would occur in exactly 14 seconds at coordinates that weren't going to move. The dam had 14 seconds of existence remaining as intact infrastructure. 8 kilometers away, the drone operator watching through his camera feed captured the JASSM-ER entering its terminal dive phase. His finger hovered over the recording control. This footage would be transmitted to military command and would eventually make it to social media platforms worldwide. The target below looked peaceful and operational, completely unaware that it had approximately 13 seconds remaining before becoming a historical landmark. 12 seconds. 11. The operated into the predicted impact point on his screen display. 9 seconds. 8. 7 seconds. 6. 5. 3. The JASSM-ER struck at exactly 342 meters per second, carrying kinetic energy equivalent to a fully loaded passenger vehicle impacting a concrete wall at 1,200 kilometers per hour. The warhead's detonation initiated through multiple channels simultaneously, creating a pressure pulse of 280,000 psi. The explosion converted the concrete structure instantly into powder and fragmentation. The shock propagated through the dam faster than a human could blink, traveling at nearly 5,000 meters per second. The far side of the dam structure experienced explosive pressures before the impact side finished collapsing. The breach widened to 70 meters within the first minute as the force of the backed-up water found the structural weakness and systematically widened it. The cascading water erosion accelerated, undermining the remaining structure, pulling millions of tons of concrete and earth away from the breach point. The crossing point that had served as critical military logistics infrastructure for 4 months ceased to exist in less than the duration of a commercial advertisement break. Iranian logistics networks just received a complicated problem they weren't planning to solve. The supply line that reached far into contested regions was now interrupted by a reservoir of water and demolished concrete. Back in the forward operating base, the F-35 pilot was executing his final approach, declaring minimum fuel status to the tower. The engines coughed as the last vestiges of turbine fuel ran through the Pratt and Whitney engines. The landing gear extended. The hook caught the arresting cable. The aircraft stopped in 400 meters. The pilot climbed out on shaking legs. The debrief would confirm that fuel reserves on landing were 380 kilograms, less than 4 minutes of flight time. The mission had been executed at the absolute edge of the performance envelope. By nightfall, satellite imagery would confirm the dam was no longer operational as military infrastructure. The strike had been successful,